Okay, I got a Pentair Mastertemp 400 and it is not turning on, so I'm going to try to do some troubleshooting on what is the problem. Hold that. Okay, the pool pump is on. I'm going to turn the spa on. Take a look here. Okay, 128, that's normal. R8 is the revision number for the software for the circuit board that's behind here. That's normal. Got a service heater light and it will not go off. So if I take this panel off, turn it upside down, I get a AFS light, as well as this is the service heater light right here on the left. So without having to turn it back upside down, I'm going to just leave this here. AFS is airflow switch. This is your airflow switch. These are your airflow switch wires. They go back to your circuit board. Your circuit board is looking for a hard short, a 0 ohm short between these two wires. So what that tells me is that there's no air flowing through this tube or back this way that makes this switch close and give me a short. That's what the circuit board's thinking anyway. So as of right now, to isolate trouble, I'm going to take these tabs off. Hold that for me. Take a look at the circuit board on the back side of it. I'm going to short these two blue leads together and see if I can get the AFS light to go out. Get those two leads in there. There. Okay, so that tells me when I short these two blue leads that the circuit board is functioning correctly and I don't have any rodent damage causing an open with the blue wires themselves. So that tells me that it tells me nothing about the AFS yet. So to prove functionality of the AFS airflow switch, I'm going to put these back on here, and I need to push air into here to make the switch throw. So I can either blow into this on the black side or I can suck on the white side. But to make this easy, I don't want to take this off of here and put my mouth on there. So I'm going to pull this tube off the back side, which is connected to the blower intake. Now the blower intake does have, feels like good flow to me, but I'm going to take this tube off. This goes to the black side, the intake side, and I'm going to blow on it, but you don't blow very hard. The switch is on a very light spring inside here, so I could do just like this. And while you're videoing that, while I'm blowing on it, take a look at the AFS and see if the AFS goes out or not. Where's the AFS? It went out. You know what? I'm going to cover this tube and see if it comes back.
Because the wind?
Oh, it's trying to do the heater. It's trying to heat now. See the heat light right here? That's the heater light. Okay, so that kind of already tells me that the switch is functioning. Just the wind, we're about to have a storm, so the wind is blowing into here. That light of a blow, just going this far away from the tube, is enough to throw the switch and turn the AFS off, the light off. So, that tells me the switch is functioning enough to give it a 0 ohm short and turn the AFS light off. Can it stay there? Hopefully it won't blow off. Something I need to be concerned with is if there's any clog in this. Nope, not at all. I can see right through it. So there's no clog in that. And I don't know how hard this is supposed to be sucking. So at this point, what I'm going to do is I'm concerned with how hard it's sucking, because the line, that little plastic tube here is clear, and this tube is clear, and this is functioning. So that makes me think it's not pulling hard enough. So what I'm going to do is I'm going to take apart the blower fan shroud I either have one or two problems, I think, at this point. Either I have maybe a dirt gobbler nest or a wasp nest or something was built in there. I might have grass or something in there to where this is actually not sucking hard enough to move air into this tube enough to throw the switch. If that's the case, I'm going to open this up and I'm going to clean it out. And if I open this up and I find it clean, then I may have a problem with the blower motor itself. It may not be turning enough RPM. It seems to be turning fine. Okay, and look, it just turned off. And it's still spinning and spinning and spinning. It's freely spinning very well. It's taken forever to wind down, so I'm thinking it's probably not the blower motor. It may be something that's caught inside the fan. So I'm going to take this off. This is 1, 2, 3, 4, 5, 6, 7 Torx head screws, and it looks like a T20 to me. Let me see. Can you open that for me, please? Yep, fits like a glove. So it's a T20. So I'm going to take those 7 apart, and this may be a little bit binding right here because this is a rigid pipe. This is the gas, an air pipe for going to the gas valve. So I'm going to pull this apart and see how the fan blades look inside it. Okay, it was actually 8 screws that held that plate on. And I got the fan shroud open, and it freely flows. I don't see any obstructions. There's a good view of it right there. Yeah, okay, so it's all clean. And I'm taking this off of this lead here, and I'm going to blow into it. That goes right back down to here, and there is a hole right there. I'm going to make sure that that's clean. Okay, it's clean. So there's no obstruction there. Okay, I got my blower motor housing put back together. Got all the screws tight. That was a very difficult process because this pipe was very rigid and this was binding a lot. But I got it all back together. I think I had more fun on my last root canal, but anyhow, it's ready. I got shut down by a rainstorm yesterday, as you saw it was rolling in on me. But anyway, I'm going to continue with the troubleshooting isolation process here. I think it's pretty important because of what happened yesterday to show you just how sensitive this AFS is. I got out an ohm meter. I have digital and analog ohm meters, so I want to show you what I mean by a 0 ohm short and just how sensitive these things are. So I'm going to take these leads back off and show you how an ohm meter works real quick. So the leads are not touching right now, so I'm reading on the red scale infinite ohms, not 0 ohms, which would be pegged over to the right. I take the leads and I connect them together. That is what I mean by a 0 ohm short. That's a hard short, no resistance between them, no resistor, no nothing, just metal. As opposed to, say, like across my fingers. Alright, so I have some resistance in human flesh. It's not as conductive as metal. I would have less resistance if my fingers were wet and more resistance if my fingers were dry. But anyway, this is how conductive I am right now, just across my hand. So what I'm going to do is put the leads, it doesn't matter what polarity, across the 2 spades of the AFS, and then you'll read it. It's currently open right now inside the AFS. So what I'm going to do is blow into this tube that is connected to the air intake, and I'm going to do it like this far away, and you'll see on the ohm meter, I hope you can see that, that's a 0 ohm short just by me blowing with my mouth 3 inches away from the tube. So that's what was happening yesterday in the rainstorm, was wind was blowing into the tube and causing the AFS to make contact and therefore shut down the AFS light on this side, and subsequently the what is that called, service heater light on the other side. And then it would then continue on with the booting up process, opening up the gas valve and then igniting the igniter after the gas valve. So I did have a chance to think about what was happening yesterday with the blower. I said there was only 2 options left in my mind. I actually have a third. I now know that there's nothing wrong inside the blower fan, and the blower motor is spinning pretty well. I discovered that. And a third option would be, if you look on the bottom down there, here's where the exit is for the blower motor. It blows down into the combustion chamber, this big tub. And here's my igniter. And if there's, you know, some type of grass clog or something that's down there in the bottom, then it'd be like putting your hand over the end of a swirl cage fan, and that would also, because there's nowhere for the air that the fan is blowing to move to, that would shut down significantly the amount of air that's going to be, the velocity of the air that's coming into the intake, and that may be what is causing insufficient velocity there, and thus triggering my AFS to not make contact in here. So I think what I need to do is probably take this off and look in there and see if maybe there's a clog on the bottom side of that, the exit of the fan. Actually, you know what, I've got an idea. What I'm gonna do, I'm gonna take my cell phone, I'm gonna take this off and stick my cell phone into the exhaust port with the video on and flash on, and I'm gonna look down this pipe and see if I can see an accumulation of anything that's inside there that may be causing poor airflow, and we'll go from there. Okay, so I just reviewed the footage of me putting my cell phone into the exhaust port there and looking down, and as you can see, if you saw it there, what I just showed you, there was only 1 coil visible before it started water, rusty water, and there's 6 coils in this tub. And there's not supposed to be any water in this tub. This is supposed to be a hellish, fiery inferno of an atmosphere in here. There's going to be tubes that do a horseshoe shape from your manifold around it and then back out, and water runs inside the tubes and fire is around the tubes and the outside. That's why it's called a heat exchanger. It takes the heat that the tubes are sitting in and cooks the water as it runs through that particular horseshoe and then spits it out and goes to your hot tub. So all of my heat exchanger coils are underwater right now, and that's going to be my clog for my AFS, because there's a small cylinder at the bottom of the fan right under there that dips down into the combustion chamber, and I'm gonna guess it's submerged, as well as the igniter. I may have a ruined igniter as well. The igniter is, like I said earlier, right there, and it sticks down about 3 inches. That's how long the leads are on the igniter, and the spark happens down at the bottom of the igniter. Well, I think it's sitting in rusty water. So to kind of prove my theory here, I'm going to do something, and I'm going to show you. I'm going to put these leads back on, but just a little bit like that, and just a little bit like that, to where these are making contact with these, but they're not, it's still exposing the spade. So I'm going to turn all my power back on. We already know I'm going to get an AFS light, and I do. I'm going to turn the AFS light off with a pair of needle nose going across the leads. Okay, AFS light is off. And I'm going to wait. This should trick the circuit board into thinking everything's okay here, and it should open my valve, my gas valve. And there it went. I'm waiting to see if it'll ignite. Yeah, it's not going to ignite. I'm telling you, the igniter is sitting in water. AFS light is off. It's not igniting. So, my little free fix, or if this was bad, that would have been about a, I don't know, $50, $100 fix. I now have what I think to be a hole in the copper tubing that comes as a whole $600, $700 replacement part. The coils themselves are leaking into the tub and flooding this thing. So and also additionally, I may have to buy another igniter if it's also sitting in that messy water there. I may have ruined it too. So I'm gonna probably maybe take the manifold off and see if the water drains out that way. Maybe the O-rings are bad. Water coming in on the intake. I had another video I posted about the manual bypass valve that's in here. It broke, and I took this apart to replace it. I didn't replace the O-rings. I feel like a dummy now, because maybe I should have, and because if there's a leak at the O-rings, that could fill this tank up with water. Or worst case scenario is maybe the copper tubing inside here themselves may have a leak. It may have corroded so much that they sprung a leak internally. So I need to either, one, take this off and look down there and see if, while my pool pump is running, if it's spraying water out of a hole that's made it somehow formed on one of the copper tubings, or take this manifold off and see if the tank drains around the O-rings that are currently around the copper tubing fittings on the end. It's a 50-50 shot for me, but it doesn't look fun. I'm gonna have to move forward with one of those two options. Okay, I chose the route of taking off the manifold again first, and the reason why is because it wasn't very long ago, like I said, that I did the manual bypass valve replacement in here. So I'm thinking I messed up something during that process that caused this to leak, because this was bone dry when I did that last process. So I've already undone just a couple of these bolts here, and out comes the water that wasn't there when I did the manual bypass valve project. So I'm gonna take the whole dang thing apart and replace it, all of the O-rings, do my best to see if I can drain whatever's in there, at least get it down there, and then I'll recheck the airflow. After I do that, I think everything will flow correctly as soon as I get all this water out of this tank. And we'll see if the igniter will ignite. We'll see if the air will flow. and we'll see if this is the only problem I see in here. I'm going to take this off. Hopefully that's it. Okay, I got the manifold off, and these were all squirting water out. It's now on the last row, so the water level is about right here right now, and it's still draining. As you can tell, I think they're even in worse condition than they were earlier. All of these are supposed to come out about this much on all of them, and they are just really thin and really rotting away. So I may need to buy another heat coil, the exchanger coil kit. As I can show you up close, these are actually very compressed. These are supposed to be round, not flat like that. So before I go off and buy another coil set, I'm going to go ahead and replace the O-rings right here and see if that fixes anything at all. I'm hoping it will, and I'll go from there. Next project though, if this happens again though, I will no doubt have to buy that $600-700 replacement part. The whole thing needs to be replaced on the insides of this. I also still don't know if I need to buy an igniter due to it being submerged in the rusty water like this for so long. So anyway, that's the situation for now. I gotta wait till it drains out. Alright, regarding all the O-rings that go around these copper fittings, my valve stem bypass kit that I got had all these O-rings in it that I didn't use, including the ones that go right here. I'm going to, this time, be smart about it and chunk them all and replace them. I'm going to show you up close why I should have in the first place. Look how smashed that first one is as opposed to how pretty and round they're supposed to be. Not smart. Don't make the same mistake I did. Replace your O-rings, especially if they come in the kit. It's that easy. There's the part number for the valve stem bypass. I got all my O-rings on there. This last one here, I literally have no copper pipe hanging out at all. I'm gonna have to rely on moisture just to kind of stick it there in place, and then while it's stuck there, get my manifold. All right, I got my manifold back on. I put all the screws just like I did, all the bolts back in like I did in the other video. Here, here, then here, then here, then down on the top, and then up on this one, and then down on the bottom, and then up on that one, and then just basically a cross pattern for equal, even distribution on the O-rings, pressure on the O-rings. So I'm now, I also replaced the O-rings in these two locations as well. There's the old ones on the floor, and I'm ready to put all of the, here's the thermistor leads. Got the HLS leads, high limit switch leads. I believe this is a just detects that there's water flow going through there. It's got a little thing hanging down in there, and if water's going through, it makes and breaks contact right there. So this is another safety. Make sure that you have water flowing in through your heater before it bothers to even turn the heater on. I have no clue what this one is. Probably another temperature sensor. I'm not sure. Okay, time to go turn the water on and see if I now have good airflow now that all the water has been drained out of the tub, and I actually have a cavity in there for the output of my fan to blow into. I should have nice, good airflow now. Wish me luck. Okay, I got all the manifold bolts back on and all the wires, the sensors wires on, and I got the pool pump running. I do still have a leak, but it's not gushing. So bottom line, I am going to have to replace the coils that are inside this tub. That'll be at least 600 bucks. And but that's going to be required to stop that drip. That's why the whole front of this tub is corroded. Who knows how long it's been dripping like that? Probably since the bypass valve was broken and I did that fix, I guess. So I'm going to turn on this back into spa. Okay, spa is turning on. Alright, there's your 128. Software revision R8. Okay, so my normal service heater came on, but it went off immediately because there's a cavity of no more water in here and it has a place to throw the air. That's blowing a lot harder. Oh yeah, and that's sucking a lot harder. So immediately it turned on the heater. Gas is running, and that's blowing hot air. Whoops, it did turn off. Yeah, it's blinking heater light again. So it's going to no longer be the airflow issue anymore. It's going to be something else now. I'm going to have to mess with this again after I replace the coils. There may be another sensor in there detecting too much moisture, something like that. I don't know. There's a temperature sensor over here. I don't know if it's got something else wrong, but it's definitely not the AFS problem that I had a minute ago. The service heater light's not on, indicating that problem anymore. So anyway, that's the fix for the AFS for so far for now, but I've still got some more work to do regarding a completely different issue that I didn't know existed. So I'll probably make another video on how to replace those coils that are in there. I got to break the seal around this tub and then take the blower assembly off along with everything that's above it, gas pipes and everything. I'll have to take the manifold back off, drop in a new heat exchange coil assembly, and then reattach it. Make sure I use new O-rings on that side again, and that should stop the leak that's happening over here. The heat exchange coil product also comes with the flame retardant pads. I think there's one on the top and bottom, but anyway, I'll replace those pads too. I'm sure they're nasty and saturated because of all the rusty water that's in there. And I'll put it all back together and we'll try it again. Okay, I just let this pump run overnight and the entire tub filled right back up again. And it was coming out the top rim and those bolts that are up there right at the bottom of the blower. So everything's submerged again. And so that really tells me, even though the seal is pretty good against the plate of the coils, the copper tubing is supposed to be tight. It's a waterproof tight seal around where the copper tubing hits the plate itself. Like it's welded or just compression fitting so much that it's tight there. So even though I think I got a good seal against the plate with the O-rings from the manifold to the plate itself, I think that the copper tubing is just so shot that it's letting water in anyway, right back in there. So this morning I came out here and went ahead and unscrewed this, just one screw, one bolt should I say, and it started. Yeah, there we go. It was peeing way out here a minute ago. As the water was coming down, pressure got less. Now it's just a trickle, but this is just the pump right now. Water pressure coming through here. This is about how bad the leak is around the that one copper fitting, if not multiple. So I'm gonna probably just leave that out, and because I don't want this to keep filling up for the next 3 or 4 days. I went ahead and ordered the coils, and they're on their way, but they'll be here in 3 or 4 days, and I got to run my pool pump just to keep the pool clean. So I'd rather have a slow, messy trickle right here than not run my pool pump at all. So anyway, the point of this video I'm gonna go ahead and stop it here because I think I showed you what the AFS light is, what it means to the circuit board, how the AFS, the airflow switch itself functions, and some things to look for if it's not showing that it's making the short. Some things that'll block airflow. So I think I've achieved the purpose of the video, which is specifically to talk about the AFS, and I'll make a separate video for the replacement of the heat exchange coils whenever I get those in 3 or 4 days. All right, have a good one.